All right, thank you for coming, everybody. My name is Max Muchler, and I'm really delighted to introduce our speaker today. For a few years now, I've been trying to get to Emily Lakdawalla here to give us one of her interesting lectures, and I'm really delighted that this day has finally arrived. I'd like to thank Jesse Doggett and the committee and everyone who organizes this engineering colloquium to make this happen. Emily Lakdawalla is a senior editor and planetary evangelist. Is that a real title? Okay. At the Planetary Society. She is a passionate advocate for the exploration of all the worlds of our solar system through blogs, photos, videos, podcasts, print articles, Twitter, and any other medium she can put her hand to. Emily shares the adventure of space exploration with the world. She holds a Bachelor of Arts degree in geology from Amherst College and a Master of Science degree in planetary geology from Brown University. She came to the Planetary Society in 2001 and has been writing and editing the Planetary Society blog since 2005. Reporting on space news, explaining planetary science, and sharing beautiful space photos. She appears weekly on the Society's Planetary Radio podcast, answering listener questions and rounding up the latest space news from the blog. Emily has been an administrator of the forum unmannedspaceflight.com since 2005, supporting a worldwide community of amateur space image processors. She's also a contributing editor to Sky and Telescope magazine. She's now writing her first book, tentatively titled Curiosity Rover, Design, Planning, and Field Geology on Mars, due out next year. And on a personal note, I just want to mention that I was a charter member as a 13-year-old of the Planetary Society when it first started in 1980. I think I still have some of the planetary reports that came out, and for a kid growing up in Wisconsin pre-World Wide Web, those things were like a lifeline for any kid interested in science and just feeling connected to the world of ideas and exploration, and so I still cherish those. Of course, now it's the social media age, but I did ask Emily, and apparently the Planetary Report still does come out in print, which is great to hear. But in the age of social media, Emily, I encourage you to check out her blog posts. I think she's one of the best science writers out there, especially somebody really good to follow on Twitter, to follow science news, especially, obviously, planetary science. During planetary science conferences, especially the ones that I don't go to, I'm really grateful for people like Emily who do such a great job of tweeting and then producing a nice summary on your blog of the meeting. I feel like I was at the meeting, even though I wasn't at the meeting. But I have a quick story regarding just Twitter, I guess. And in November 2014, I believe Emily was embedded at the center of activity for Rosetta's Philae landing in Darmstadt, right? ESOC, it's an ESA mission, right? And coincidentally, at the same time, there was a planetary science meeting going on in Tucson, the Division of Planetary Science, where many of the U.S. Rosetta scientists were attending. And so as you can imagine, we got one of the ballrooms and set up, video equipment and everything to see the press conferences and everything. And, there's a lot of excitement. It's pretty rare to actually be in the same room with a lot of colleagues for an event like that. So a lot of excitement. And just at the moment of truth, when we know Philae was landing, there was, of course, a bandwidth problem, right? And people were scrambling, and we couldn't get video, couldn't get audio, and you can imagine there was a lot of consternation and frustration. And then somebody in the back of the room yells out, "Emily Lakdawalla just tweeted that Philae has landed." I don't know if you've heard this. Okay, I assume you probably did. But so that's how we found out, that moment happened. So, my parents' generation gathered around their TV sets so Walter Cronkite could tell them the Eagle had landed, right? And our generation gathers around iPhones so that Emily Lakdawalla can tell us that humanity's landed on a comet. So please join me in giving a warm welcome to Emily Lakdawalla.
Thank you very much, Max, for that introduction. I am the senior editor and planetary evangelist for the Planetary Society, which is a title that I wrote for myself. The Planetary Society's mission is to educate the public, to advocate for space exploration, and to encourage development of new technology that will enable discoveries to be made in space exploration. And today I want to talk with you about the work that is being done by members of the public to dig into data archives and to present some of the amazing imagery that's being captured by all of these robotic spacecraft, and to actually help the process of space exploration, help the public learn more about what's going on with space exploration through the wonderful images that they present. So as just a little note before I proceed on the image credit, many of the images in here are from NASA JPL. Those are all in the public domain, but most of the images, in fact, are processed by members of the public. Once they do that, it's a derivative work, so it may be copyrighted. I have permission to put them all in here. They're generally very happy to share with the world as long as they get credit. So I first became interested in space exploration, planetary exploration, with the Voyager flybys of the giant planets, especially Uranus and Neptune in the 1980s. They introduced me to these interesting new worlds that had never been seen before, the moons of Uranus, in all their diversity and variety. And I realized that there were new worlds out there waiting to be explored. The rest of the 1980s were not particularly good for planetary exploration. There were a couple of missions going on. There was the Russian exploration of Venus, which I don't know about the rest of you, but I had no idea that this was happening at the time. I had never seen those images before going to graduate school, but they were pretty incredible, what the Russians did at Venus in the early 80s. And then, of course, there's all the excitement about Halley's Comet. But Halley's Comet, the excitement was being broadcast live on the BBC when the Giotto spacecraft flew past Halley, and this is what they showed people. It was generally uninterpretable, even to people like James Burke, who really, really tried to explain what those images were. But famously, Margaret Thatcher was so unimpressed by the images from Halley's Comet that she defunded planetary exploration in Britain for the next decade or so. But things began to look up in the 1990s. So I had gone to college and I studied geology. I went on to become a middle school science teacher teaching 5th and 6th grade science in a suburb of Chicago. And this very charismatic little robot named Sojourner landed on Mars. And it was right at the dawn of this new thing called the World Wide Web, where you could go to your computer and you could dial up with your modem and you could download these 30 kilobyte images that were fresh from Mars. It was so exciting. It was also very difficult for JPL at the time. JPL, this is a screen cap from JPL's website where they suggested other places around the country and the world that you might be able to find a website that had not been brought down by the tremendous amount of traffic that was going to see these exciting new images from the surface of Mars. There's one of them, this is like a little independent school in Oregon. You know, there's like all these, JPL was doing everything they could to try to satisfy the demand for these exciting new pictures from Mars. And at the same time, Galileo went into orbit at Jupiter. And again, my excitement for these strange new worlds that were so diverse and interesting was just rekindled by these tremendous images that were being returned by Galileo. Of course, there were other exciting spacecraft taking cool photos of planetary targets at the time. These are all with Pic-2 images from Hubble. You've got Io and Mars and Vesta that were regularly sticking planetary targets into the news cycle and getting me very excited. It made me realize that perhaps I could possibly be a geologist on other planets. And so I talked with my advisor at college, and she suggested where I could do that, and I wound up going to Brown to study Venus tectonics. And while I was at Brown, so this is a radar images of Venus, while I was at Brown, I made a discovery that would change the rest of my life. And it wasn't a scientific discovery, exactly. The discovery was the fact that there were spacecraft, quite a few of them, that returned images, a lot of images, and there were these huge, vast archives of planetary image data that were all free and available to the public, and you could access them on the internet. And I said, how come I've never seen all of these amazing images before? I want to play with these images. I want to teach people that these images are available. I mean, I would just go, I was supposed to be working on my thesis, but instead I would go into the Regional Planetary Image Facility at Brown and rifle through all of the cabinets after cabinets of images from Magellan and Lunar Orbiter and Viking that they had there. And it's really what I wanted to do, was to dive into image archives, come up with images that people hadn't seen before, like this jellyfish on Venus over here, and educate the public about what we were seeing on the surface and teach them that they could go into these archives on the internet and find brand new image data. So I had really found my calling, but I wasn't sure where I was going to do that yet. Fortunately, a couple years later, I wound up at the Planetary Society. This is a photo that was taken a couple years before I arrived there of the 3 founders of the Planetary Society. I arrived there actually at a really excellent time in planetary science. It was in 2001. There were exciting things happening. We had Deep Space One flying past comet Borrelly. We had Cassini got its very first images of Saturn at that time. It was approaching Saturn, still had a couple years to go before getting into orbit insertion. We had Mars Odyssey just arrived at Mars, making count them, two orbiters at the same planet at the same time. Just imagine. It never happens. Now, of course, we have 5. And then there was the Stardust flyby of Wilt 2, which was just so cool to see this strangely shaped space potato that was venting gases into space. There was just so much exciting stuff happening in planetary science at that time. It was a wonderful time to arrive at the Planetary Society. So I had gone there to work on a public education project. And so I was working behind the scenes on this Mars Exploration Rover project, and I was working with these two guys, Steve Squires and Jim Bell, who had a revolutionary idea. Their revolutionary idea was, we are in charge of a little robot that is going to be landing on Mars pretty soon. That robot is going to be taking color photos that will be very cool. It's exciting to see color images come back from the surface of Mars. Therefore, we should take all of the images that this robot captures and stream them directly to the internet so that the public may enjoy at the same time that we do the exciting new pictures from Mars. And the people at JPL said, no, you don't want to do that. You want to keep all the data so that you can do your science and then release it a year later, and we'll just put out a couple press release images. And they said, no, that's not what we want to do. We want to invite the public along on this exciting journey that we're going to be having across the surface of Mars. And so that's exactly what they did. From the very first moment of landing, these are the first images that were returned from the Spirit rover on the surface of Mars, sent directly to JPL's website, so that you could download them. These images were taken even before the mast had deployed. The rover's mast was sitting down like this, and it was looking down the mast. It took the very first images after landing, then it popped up and took the rest of them there. And just from the very moment after landing, the public was invited along to enjoy the adventure of exploring across the surface of Mars. This idea paid immediate dividends. Instantly, a worldwide community of people sprang up around those images. And what I'm showing you here is a screen cap of a forum called unmannedspaceflight.com that had actually been founded when Beagle 2 was approaching Mars. And Beagle 2 was never heard from again, so they quickly switched over to the Mars exploration rovers. And all of these little words here are titles of discussions happening about different parts of the Mars exploration rover journey. And they download images. They're like, wow, look, we see a dust devil in this one. And oh, let me make a panorama, and have all kinds of fun with these photos. And it was an instant worldwide community was created around the release of those raw images. I wasn't actually aware of this at the time. I was still working behind the scenes on my little education project on the Mars Exploration Rover mission. But after that project ended, happened to coincide with the time that Cassini arrived at Saturn. And Cassini, the JPL Public Information Office, had seen what a huge success the sharing of the Mars Exploration Rover images had been. So they used exactly the same procedure to send Cassini images directly to the internet. And so when my project ended, they said, okay, you're a geologist. We've got so many space missions. We don't have enough people to cover all of them. You cover Cassini. So I got to start writing for the Planetary Society, covering Cassini, using these raw images and having fun with my little geologic interpretations of this first flyby of Iapetus and all kinds of the other amazing little moons of the Saturn system. So it was in that capacity, working on educating the public about the Cassini mission and all the cool images that it was doing, that I traveled to the European Space Operations Center in Darmstadt, Germany in January of 2005 to witness the landing of Huygens on Titan. And I was doing that as a part of a Planetary Society art contest that we had run, where we asked people to guess what the surface of Titan was going to look like and represent that in art. So this is one of the winning art works that was submitted as part of that contest. We actually had 2 contest outcomes. We had one set of selections that was done before the landing, where we just judged based on artistic merit. And then we had a selection that we did after the landing, where we judged based on who got closest to what it actually looked like. And this was one of the people who won in both categories. So I wasn't actually technically there as a member of the media. I was sort of a member of the education public outreach team for Huygens. But I was also writing for the Planetary Society website about this landing. So this was a European mission. We knew that Huygens had left the spacecraft safely. We knew that they had picked up a radio signal. There was something weird about one of the two channels not working, but one of them did, so everything seemed fine. The spacecraft is fine. And then they gathered us together in their big room to give us a big show about the landing. And there was a formal dinner, and there were a lot of lectures and a lot of thanks for government ministers for their work in supporting Huygens. And we were like, okay, we know, how about the data? How about the pictures? How about the results? Where is it? And they thanked more government ministers, and they had more speeches, and then they put this image up for about 5 seconds, and then they took it back off the screen again, and we were like, what? What was that? That was so amazing, and it was just one photo, and then they didn't show us any more photos for many minutes, and all the media were sitting there saying, maybe something went wrong. Maybe there were no images. Maybe that was the only image that we ever got. You know how media are. They're all conspiracy theorists. So I'm saying that because I'm a member of the media now. Well, meanwhile, while I was trying to figure out what had happened to all the data, I got this email that said, hey, you should go check out this website. Somebody at the University of Arizona says, now without further ado or commentary, the DISR team proudly presents all the images from Titan. And they had, in fact, posted every single image from the Huygens mission. Now, I knew that these were not supposed to be out there, so the first thing I did was I downloaded them all, and then the second thing I did was I sent an email to somebody at the University of Arizona saying, hey, do you know that those things are up there? And they did not, and they took them down in about 20 minutes. But the damage had already been done because many other people had the same instinct that I did, which was to download them all first. And all over the internet, amateurs were producing these mosaics, these beautiful views of this brand new world that we were discovering for the first time, this shoreline on Titan. It wasn't clear what this stuff was. I mean, my first impression is that it looks exactly like Long Beach, and that here's an ocean, and here's the waves, and there's the shoreline, and it's all dry. It's not actually. It gives you the visual impression that it's a wet ocean, but it's not actually. It's incredibly cool going through all of these images. Meanwhile, the Huygens team they only released about 3 images that night. And the next morning, they finally released their version of the panorama, which was this, which is also very nice, but it's not as seamlessly cinematic as that previous image was. And on the same day that the mission formally released this version, the person who produced that other one released this version, which really looks like Titan. It was absolutely amazing. So after that experience was ended, I had one main question, which was, who are these people who are out there grabbing all this data, doing all this amazing work so fast, and how can I help them? Perhaps not necessarily by making them get access to data that they shouldn't have access to, but trying to see what they can do with all of the data that is publicly accessible, because there is an awful lot of it. So after many years of experience working with members of the public who are interested in processing space image data, I sort of see them as divided into 2 groups. And I'll talk about a group that I call artists first, and then the group that I think of as explorers second. So the artists want to know, they want an answer to that question, which is, what would it look like if I were actually there? So to the artists, these robots, these spacecraft that we're sending all over the solar system, are our avatars. They're they're representatives of humankind venturing out into space, exploring all these worlds that we can't physically explore ourselves right now. They are our eyes in the solar system. When scientists process image data, they typically are trying to answer scientific questions. They're trying to understand they're trying to map different worlds, understand how different terrains vary from place to place. They're trying to understand how various physical processes affect the surfaces of worlds. So they have one particular way of processing images. They tend to stretch the contrast greatly, so you can really tell the difference between the brightest brights and the darkest darks. Scientists use wavelengths that aren't accessible to human vision. We have radar image here on the left and an ultraviolet image here on the right. These are both the planet Venus. These are 2 of the most common representations of Venus that you will see on the internet. And one of them was produced by Magellan, one of them by Galileo. And of course, they don't look anything like what Venus would actually look like if you were there. Here is one version of what Venus would look like, or it's one attempt at answering that question. This is based on Mariner 10 data. And you can see Venus is actually very cloudy. You can't see the surface. But even this, with its very, very subtle yellow cloud features, is too extreme a representation of Venus. If you want to know what Venus would really look like if you were there, you need to look at messenger data. And this is what Venus would look like if you were there. That is a color photograph, by the way. And so this is scientifically useless, but it is what it would feel like to actually be able to see that with your own eyes. That is Venus right there. Okay, so another example is this one showing two most common representations of Neptune and Uranus. And so again, you have this deep, dark blue atmospheric version of Neptune with its bright white clouds. And Uranus, for reasons I don't quite understand, is often shown as this almost cyan color. And there's another amateur who asked the question, can I get into the Voyager data sets and process two sets of images the same way so that I can see what Uranus and Neptune would actually look like if you put them close to each other? And here's the answer to that question. And you can see that they're still visibly different, but they are much more similar than you typically see when you download those images off the internet. And they have this interesting sort of limb graying where they get much less colorful toward the limb. And I suspect that if we sent Voyager 2 to Uranus today, that it would look even more similar to Uranus because of the amount of cloud activity and everything that we're seeing there now. One final example of this is here's an image of Saturn that I see all over the place. This one uses ultraviolet data from Voyager 1, I think. And it's just psychedelic. And here, I actually couldn't find an amateur version of this image, so I asked last week for Ian Regan to make one for me. And so he went to the data set, he found at Saturn at a similar time in visible wavelengths, and that's the same, nearly the same observation reproduced as it might appear in visible wavelengths. And so they really want to know what it would look like if you were there. And one of the reasons that I harp on this is because the public doesn't necessarily understand what's false color, what's true color, what would it look like if I were there. And so you wind up with things like this, which is a kind of fabric that you can buy. You can go down to your local Joann Fabrics and buy this cotton fabric, quilting fabric, and you can recognize the Saturn that I just showed you. And you can see the orange Venus and the green Uranus and the blue Neptune are all faithfully represented on this piece of fabric, which I'm sad to say my mom actually used to make a baby blanket for my infant daughter. And I love the fact that she made me the blanket, and I just laugh at that Saturn every time that I see it because it is so not Saturn. So this, after assembling all of the images that I could find that amateurs had put together of true color representations of planets, this is an attempt at showing the true colors of the planets. It's perhaps a little more intense, a little brighter than it ought to be, and I haven't tried to match relative albedo. But the colors are more or less represented, and you can see even all the little moons, and I've got the Kuiper belt down there in the lower left corner as well. All right. So what do these people need from professionals in order to do the work that they do? Obviously they need the data, but they also need metadata describing the observations. They need information on filters and all of that other timing and geometry, the presence of other moons and images, all of that kind of stuff makes it easier for them to locate and download and use the data. They need browse tools to make it easier for them to find images of interest. They need tools that make it easy to download large amounts of data, but only the data that you want. So you don't have to download an entire multi-gigabyte data set in order to then browse through it and be able to find things that are interesting to process artistically. They also need easy-to-use processing tools. This is one of the bigger hurdles. It's pretty easy to use GIMP or Photoshop. They're fairly interchangeable in order to make color mosaics and things like that. But it is extremely difficult for members of the public to calibrate data, to flat field it, to reproject it geometrically. All of these things we can do using tools that are available from the USGS, or different missions sometimes provide them. Sometimes they're available in IDL, which the public can't afford. And so if there are widgets that can be made that might work inside a browser or work on a desktop in order to take raw data and calibrate it, or even better, if people archived calibrated versions of data sets so you wouldn't have to worry about calibrating it, it would make these people's work a lot easier. Here are just a couple of my favorite places to browse and find data. The PDS is the Planetary Data System. It's NASA's repository for space image data. And they have different disciplinary nodes, and the RINGS node is awesome. They have produced many really easy-to-use browse and search tools for data from missions that have explored the outer planets. For Mars data, the Arizona State University has a really great both map interface and web interface to get to data sets from many, many different Mars orbiter missions. And then Midnight Mars Browser is a amateur-produced interface to all the raw images that are being released by all of the active Mars rovers. And that's my go-to site to find Mars rover images. So here's just a screen cap from the RINGS node browse tool. I asked to see images of Saturn. And one of the cool things that they do is that they color code all of the thumbnails of the images to tell you which filters were used to take these photos. So the gray ones are clear filter images. The green ones are green filter, blue ones are blue filter, violet ones are violet filter. It's really easy to find multispectral image data sets when they set things up so easily for browsing. And the RINGS node actually archives Hubble data. So here are Hubble observations of Saturn. And I have not used it to retrieve retrieve Hubble data before, but it's definitely in there, so it can be at least browsed. So that's pretty useful. And finally, the raw image releases are a terrific on-ramp for people who are just kind of recreationally interested in space image data. The way that JPL has encouraged the raw release of the rover images, and then Cassini, New Horizons released most of their raw images. It really helps people get the bug for processing images, and then that helps them develop the skills that they need to go into these data archives and be able to produce beautiful photos. What do you get when the artist? Well, obviously you get really gorgeous illustrations. They produce useful illustrations, and you can actually ask them for things. Or you can have people like me who go to scientific meetings and get really frustrated by the quality of some of the illustrations that I see. So then I help produce illustrations that make people's communication a little bit easier. But just as an example of some of the gorgeous illustrations you can get out of the amateurs, this is a representation of every single image of Miranda that Voyager 2 ever got. There's not very many of them. And you can see that there is one high-resolution mosaic where they took like 8 photos that cover all of Miranda. But Voyager 2 was moving really fast as it took this set of images. So there's a lot of parallax. It's a very difficult mosaic to assemble. If you go to JPL's website and look for versions of this mosaic, here are the 2 that are available from the JPL website. On the left, you can see one where they didn't struggle with the parallax. They just assembled it as best as they could, and it's got gores and it's a big mess. And then on the right, you can see one that was produced by Paul Schenk as part of the mapping operation, where they reprojected everything to a map, they mosaiced everything together, and they projected it back out again onto a sphere. But Miranda is not a sphere. Miranda is lumpy. And so this representation of Miranda looks flat and weird. It doesn't really represent Miranda's nature as a world. And so here is an amateur version of that mosaic. And if you look at it really closely, you'll see where there has been fudging. Things have been warped and stretched and squeezed in order to fit together. But stand back from it, and it looks more like Miranda, the entity, than these two do. These are science products. This is a communication product. And so I'm very happy that there are people in the world who can take such a gnarly data set and produce a beautiful photo like this one that really represents what Miranda would look like if I were there. Let me go back to these Venera images that I showed you at the beginning of the talk. Venera was another really gnarly data set. The camera was a scanner that was mounted at an angle, so it swept up to the horizon and then down to the center and then up to the horizon again. And so you just get these 2 little bits of horizon and a lot of ground in the middle. So you don't really have a sense of what the scene on Venus would look like. And here again, this amateur, his name is Ted Strike, he took those 2 images and kind of cut and pasted them together. He collaged them. This is not the landscape that was in front of Venera, but it's an artistic representation of what the landscape would have looked like if you were there. Here's another image that he produced from another gnarly Russian data set. This is Mars 3, a view of Mars on its approach. And when I first saw this image, I said, I've never seen a crescent image of Mars like that. That is so cool. And I made that remark and somebody else commented, you know, Viking took crescent images of Mars too. And I said, really? I've never seen any of those. So I went on the JPL website and I found this. This is a GIF compressed, downsized version of an image scanned from a lithograph. And this is what's available for download on the JPL website. So I said, fine, I'll make it myself. I went into the Viking image data set, and I couldn't believe what I found. This. It's the same data set. It's just different computers. It's not even, I don't have any particular skill at image processing. It's just the fact that it's so easy to do it now with Photoshop and the powerful computers that we have that you can dig into the data sets and get these beautiful, gorgeous images. These are all Viking approach images of Mars. Finally, one more of the gnarly data sets that I mentioned earlier in the talk. This is what the Giotto Halley data set looks like. It's all skewed, it's a really tiny detector, and the spacecraft, as it was flying past Halley, was getting whacked by debris, so the camera's like going back and forth like this. And it's really hard to see what's going on in the images, but there's a group project by several amateurs on unmanned spaceflight to take all of those images and produce a stabilized animation. Oh, first of all, here's just a portrait of Halley. Again, a somewhat artistic representation of the image data that you saw before. But here is the approach animation. And you can see the images have been reprojected and aligned, and you can even see a crater on the surface of Halley as we approach it. And this is an amateur-produced visualization. Isn't that cool? And then boom, the camera got whacked by a piece of debris and it didn't work anymore. So that's the kind of beautiful visualization you can get out of amateurs. This is the one that I was talking about where I got tired of seeing really bad montages of asteroids that have been visited by spacecraft. So I put this one together. Everything's to scale. I did my best to represent everything in the correct relative albedo. And then one of my favorite tricks for montaging images together that have been taken by different spacecraft at different times is to rotate them all so that their terminators are parallel. And that makes it feel like they're all being illuminated by the same light source. And it makes them all sit on the page as though they all belong together. And here's another product, a group effort, eventually assembled by Mike Malaska, asking what do all these different worlds look like that we have visited on the surfaces. And he was very careful to represent Earth as an ocean planet, which is what, of course, it is. And we need to add a comet to this now. Okay, not only do they do good work, but they're fast. So here, there's one guy, for instance, who produces these amazing VR 360-degree panoramas from Curiosity rover data within like a day. And they're gigapans. They're VR panoramas. You can swing them around yourself. You can crowdsource your PR. You can just let these people go. They do amazing work. And one thing that you can't do is you can't tell them what to do. They follow their own interests. And so you have some people who really love Titan. You have some people who really love Mars rovers. You have some people who think Hubble is just the greatest. And then you have other people who do a little bit of everything. And so they just go to whatever interests them. This particular guy has been doing some amazing work in the Mars Express data set, finding images that have high-level atmospheric hazes and things in Mars, which I think is pretty awesome. And so if you go to planetary.org/amateur, you'll get my image archive that I've been doing my best to assemble some of the greatest examples of the work that these people have been doing in order to process images. You can go look at individual people's contributions, or you can just slice and dice it by the different planets. And it's pretty cool what they produce. If you're looking for an illustration, again, not so much science, but things that have high illustration quality, this is the place to go. All right, so let's talk about the explorers, the other group of people. Their question is, what's happening now? What's over there? Are we there yet? They're following everything as it happens, and they're excited about the adventures that we're having across the solar system. So this is what happens on unmannedspaceflight.com. And there are several other forums. This just happens to be the one that I'm familiar with. I'm an administrator there. There's a variety of forums with different personalities. On this particular forum, we discourage with a hammer conspiracy theorists. You may only be, it's very scientific. We encourage participation from scientists and engineers. There are other forums where it's a bit more free-for-all, and for some people that's a lot of fun. For me, this is where I'm at. And so people download images from Mars. They immediately assemble the mosaic so you can see the 360-degree view around the rover. They say, oh, here's where that drill site was. And so here somebody has actually made a map with a scale bar and shows where the drill site was recently. There are people who are mapping the entire progress. This is done in Google Earth. Somebody is mapping the route of the rover. This is not a JPL product. This is just some guy, I forget, I think he's Spanish, is mapping the progress of the rover. And then there are some people who kind of combine the artist and explorer thing. And here's one person, Sean Doran, who likes to drop rover models into panoramas just to give people a sense of the scale of what it is that we're looking at. One of the interesting things about this particular forum is that there is a very high lurk to post ratio. So if you look at some of the recently active threads, there tends to be like a 500 to 1 view to post ratio. And we're very into maintaining high signal to noise, where the posts are content. They are curiosity moved today. Here's a new panorama. I noticed this interesting feature in a rock, as opposed to lots of yay and that's cool and oh, it's an alien over there and that kind of stuff. All of that chit chat gets deleted, and we maintain a very high signal to noise. But you can see that there's a active route map, what's going on currently in the mission, but also discussions about how to process the data and what was going on a long time ago on the mission as well. So what do these people want? They love the raw images. They love it when missions instantly release new data that's coming down from a spacecraft. That helps them follow the everyday goings-on of the mission. What that means is that they want the raw images right now with no delay. Don't give me a one-day delay. I want to see it as soon as it's arrived on Earth so I can follow every second what's going on with the spacecraft. They are very demanding. Oops. So here are just a few examples of planetary missions. Actually, these are all the ones that I know of that provide raw images. The Mars exploration rovers set the stage. Opportunity is still doing it. Cassini is still doing it. Mars Express, European mission, has this little tiny camera called VMC. It's basically a webcam. It's a 640 by 480 color camera. And it can take global images of Mars. They're very low quality, but they're very cool because it's the whole planet, and that's pretty neat. All the cameras on Curiosity. After a short delay, we get the images from New Horizons LORRI. We get those once a week, and we get all the images that are 4 to 10 days old. And then we start getting into the missions that don't release raw images, but produce science archival quality data as fast as they possibly can. So Rosetta's NavCam gives you PDS quality data, the science quality data, within now 4 weeks is their goal. So they try every month or so to release data that's 4 to 8 weeks old. And the fastest planetary image data release that I know of is HiRISE, which whenever they do a quarterly release, they release data that is only 1 to 3 months old. And that is a lot of Mars data. So people should spend a lot more time in the HiRISE. It's the highest resolution camera on the Mars Reconnaissance Orbiter. It's the one that can give you the hiking map quality images of the surface of Mars. I'm not an expert in astronomy or solar observing, but I did go try to figure out who in those fields is providing raw images. The solar missions produce a huge quantity of science archival quality data that is instantly released, which is just fantastic. I also learned recently that the Hubble Director's discretionary time data is instantly released, which is awesome. And I don't know of others, but that's probably because I'm ignorant, not because they don't exist. So if you know of other telescopes or astronomy spacecraft that are releasing data very quickly, please inform me. So the explorers, they want that data. They want it fast so they can follow what's going on in the mission. But they don't actually care so much about data quality. So all they want to do is be able to see what's around them. So you can compress the heck out of the data. You can even reduce the resolution if you started out with very high resolution data. Because what they really want to do is just follow along. They're not there to produce science. They just want to enjoy the adventure. So they're willing to deal with compromises in data quality if it means that they can get the data faster. Metadata is important for explorers as it is for artists because the metadata tells you why they took the pictures. The Mars exploration rovers have done a fantastic job with this. They release a lot of the metadata that the scientists use. So things like the names of the targets, the names of observations. All of that is in there, which tells you what the names of the little rocks are that are on the pictures, what the goal of the observation was. That's pretty much the only mission for which we get all of that information right away. Even Curiosity isn't releasing so much data, and Cassini releases very little metadata. They don't even tell you what time the image was taken. You get the date, and you get the filter, and you get the intended target, and that's it. But that's enough to help you play around with the data. You don't need to translate the often arcane acronyms and codes that are associated with that image metadata, because there's always some experts there who have read every paper, who have followed the mission from the beginning, and who can translate what's going on. And so they'll participate in the forum. They say, oh, this one's targeted at blank, that they're continuing this, that, or the other thing. And they can help the rest of the community understand what's going on. So just one example of an awesome amateur-produced product is Midnight Mars Browser. It's now an iPad app, but it's also available on the web, and it's amazing. It automatically downloads all of the metadata for rover images and can assemble them into VR panoramas that you can actually use your finger and spin it around 360 degrees. It can put up anaglyphs, so you can look at it with your 3D glasses. And if you see the little line that's snaking across the screen, that's actually the rover's course. And if you tap on any sol number, your screen will zoom up to that position where the rover was in that sol. And so you get to actually explore the surface of Mars. And this is an entirely 100% amateur-produced product. It's available for sale in the App Store. It's often free. I think he usually charges $1 because he's found that when you offer apps for free, the reviews go down. And so if you make people pay, then it's people who actually were interested in the product. So, but he doesn't make any money from that. He makes all of his money from a Mahjong app that he developed. So this is just what he does for fun. Just a Minnesotan programmer. So what do you get from supporting this community? Well, you get up-to-the-minute situational awareness. These people know what's going on at all times. They're often faster to note when things have happened, when important events have happened on the mission. And that can actually be of use to members of the scientific community. So this is Steve Squires, the principal investigator of the Mars Exploration Rover mission, saying that in the morning when he wakes up, the first place he goes is unmanned spaceflight, because I know I'm going to get the mosaics there rather than just the raw images if I go through all the firewalls to the JPL website, because nobody in Pasadena has even woken up yet. Because half of these guys are these amateurs, they're in Europe. And so they're working overnight while the rest of us are asleep over here in the US. And so people on the mission, they just wake up in the morning and they can go to unmanned spaceflight. All their mosaics have been produced. They see what the progress of the mission was. They don't have to read any of the reports. They're on top of it. They also, because these people, and when I say these people, I'm actually including me, they have time to go through the pictures, which not every member of a mission actually has time to go through all their pictures. And so they can realize things that people aren't necessarily on top of. So one example that I thought of recently was I was participating in a telecon about the development of the next Mars 2020 rover camera, and somebody said, I wonder if we can see the MOLLE calibration target with our camera. No, it's usually in the wrong position. And I was like, oh, wait a minute. I happened to notice here at unmanned spaceflight that thing was visible in an unusual location when the arm was in an unusual position. And it's just because I am one of the people who's been going through all of these images day by day by day by day. And that's just one example of the kind of knowledge of imagery that is available in the collective conscious of all of the people who have been following these missions day by day by day. They're also devoted to missions. They are informed and they are advocates for space missions. And so they provide a very useful internet conspiracy debunking service. So here's one of my favorite examples on the important website Encounters with the Unexplained of a Sasquatch that Spirit observed on Mars. And this was all over the internet. It was absolutely amazing. Well, over at unmanned spaceflight, people were like, it is a funny little figure. I mean, it looks like a little figure furtively dashing across the surface of Mars. There he is. Yeah. And so over in the forum, we figured out that Spirit had observed this thing on multiple sols. It wasn't just seen on sol 1367. It was also seen on sol 1364. So if this is Sasquatch, it's a very slow-moving Sasquatch. And I wrote about that, and then here we basically did all the research so that Phil Plait could write a debunking article about why this Bigfoot was not actually Bigfoot. It was also very small. It was about this tall. So apparently Martian Bigfoots are very tiny. It also helps when the professionals make mistakes. So here is an image of a lake on Titan that was released by JPL, and some members of the internet conspiracy community noticed all of the cloning that had happened in a dark region on the lake, where if you saw these features, it's the same thing repeated over and over and over again. And why was this in an official NASA release? Well, what had happened was that somebody who was doing a talk on Titan, I forget why that area wasn't dark in the image, but they were just doing their talk. It was a pretty illustration. It was probably their title slide. They fixed it in Photoshop, put it up on the title slide. Somebody else said, oh, that picture is lovely. Can I have it? And without thinking, they said, sure, you can have it. And then it goes up on the JPL website, and they have egg on their face because it looks like they really have been Photoshopping and painting something out to hide the alien bases on the surface of Titan. And so because the unmanned spaceflight, because the amateur community understands what was actually going on here, we were able to contact JPL and not say, you're hiding the alien bases on Titan, which is how most people were approaching JPL. We said, I think maybe somebody may have edited that image in a way that probably was not appropriate. And they said, oh yes, that is bad. We will replace this image with one that has not been edited in this way, and they did. So I have a couple of stories I like to tell about real successes where the amateur and professional communities have worked together to accomplish amazing things. One of them started out in 2006 when John Spencer posted to unmannedspaceflight.com saying, maybe you guys can help us out. We have just launched our spacecraft to Pluto, and thank goodness the launch happened successfully, and now, oh my God, we're only 1 year away from Jupiter. So we are going to be flying past Jupiter. It's a gravity assist flyby. We're going to do it anyway. We're going to try to squeeze as much science as we can into this flyby. One thing that we don't have time to do is to figure out when would be good times, good opportunities to shoot pretty pictures. And Jupiter is a place where you really want to try to shoot some pretty pictures because it's such a lovely landscape. And so John came and said, maybe you guys can help us out. Here are some visualization tools that we're using to plan our science. Can you please look for Kodak moments, photo opportunities? So I want to point out the time, February 7th, 2006, 8:38 a.m. And 5 hours later, this person had gone through the entire encounter and came up with this observation as being one of his favorite. He actually came up with a list of 7 observations that he thought would be good. But here is Io and Europa together, and that's one of the images that came from New Horizons, a color photo of Io up here and Europa down there as New Horizons was speeding past Jupiter. They actually took it with both their color camera and their black and white camera. They released the 2 images separately, which I thought was really nice because it meant that the amateur community could then use the color image to colorize the black and white image. And here's 2 different amateur-produced versions of that particular observation. This one, I want to point out, is made by somebody named Exploit Corporations. I have no idea who they are, but they do amazing image processing work. And here's another one of the suggested Kodak moments, which was shot by New Horizons. And here's the last one showing Europa against Jupiter's limb as New Horizons was departing. And I'll back up real quick to show you. After that, we gave Hendrik here, I don't know, Richard Hendricks is his name, but he has a new title on unmanned spaceflight, the Director of Galilean Photography. Okay, so that's New Horizons, and now there's a new experiment going on. So this is the Juno mission, which is about to arrive at Jupiter. And it takes images that look like this. It has a weird camera. It's a push frame camera on a spinning spacecraft. And so there is some assembly required to its photos. This is a photo that it took during Earth flyby, and this is what the Mail and Space Science Systems released on their website, and the same day, this is what an amateur produced from that image data set. This just gives you a taste for how awesome Juno's images are going to be of Jupiter. And I want to back up to show you a little thing that Gerald added to this photo, which was a logo for the JunoCam Virtual Image Processing Team. So now we have our JunoCam Virtual Image Processing Team that's going to be really looking forward to the amazing images that Juno will get at Jupiter. I do want to mention that Juno will not be getting those amazing images during orbit insertion. We have to wait until August 27th on the first periapsis in order to get the first really high-resolution image data from Jupiter. So when JunoCam does start getting images, they right now they're inviting amateurs to contribute images of Jupiter in order that they can get some situational awareness for what Jupiter is doing right now to be ready for image acquisition. And then later on this year in November, they'll start inviting the public to process the Jupiter images. All right, so challenges with the amateur community. One of the interesting things that I've seen happen in the last few years has been a fragmentation of the community. It used to be that we all lived on this one forum. There were maybe 3 or 4 forums out there. But now with all of these social media, with Facebook and Twitter and Instagram and Flickr and everything else, there's been a lot of fragmentation. People aren't gathering in one place anymore. People are just posting their own photo sites and maybe sharing links to them on Twitter or whatever. And there isn't a gathering place where you can find all of this stuff, which is one reason why I made that planetary.org/amateur page. I'm doing my best to gather all of the best work that I can find, but there's a lot more out there that isn't really being gathered in any central location. Another problem is the kind of Reddit culture where people share images without credit. And all of these amateurs, they do it for the love of it, they do it for the fun of it, but it is a lot of work. And so all they want is that you name them and thank them for their work. And so when credits get stripped off of images, they get very frustrated and they don't want to share their images anymore. And so that's why I'm always extremely insistent about making sure that you, and it doesn't take much, you probably saw that throughout my presentation, I've put the image credits in gray on the bottom of the screen. It's not obtrusive, but I want to make sure that people get named and thanked for the work that they're doing. But even with all these challenges, there's still a lot of fantastic work being done by people around the world with all kinds of amazing image data sets from so many spacecraft exploring all over the solar system. And I can't even manage to keep up with it all because they're digging back into really ancient archives as well as using some of the most beautiful latest image data. And it's just been really fun to be part of this community for so long, and I hope that I manage to keep it going into the next century. So thank you very much for your attention. I'll take any questions.
Thanks, Emily, for a fascinating talk. Do we have any questions? John?
So correct me if I'm wrong, but I think a lot of the large programs also don't have proprietary periods, right?
Some, yeah. Like some of the big,
Large
yeah,
programs.
legacy, large and medium. Okay.
Thank you.
Scott?
So when you were talking about the release of the Cassini data and that they only included some of the metadata, the date and filter. On the one hand, I'm surprised that some of it comes out so quickly because astronomers really like to calibrate their data before it's. On the other hand, I wonder why, in that case, so little is why, for example, is the time not included?
So the question is with Cassini, so yes, you do understand why it would be nice to have calibrated data. That, in one sense, it's actually a virtue that they do the automatic stretch and the JPEG compression, because then you don't expect the data to be of any quality. You're using it just to see what the spacecraft did. I often take Cassini data, like for Titan, which is one of the more colorful things in the Saturn system. I'll download a red, green, and blue image, you put them together, and it looks basically white when you're done with that, except that it gets a little bluer toward the edge because it's all been contrast stretched. So I go and take one of Gordon Nugarkovic's beautiful images of Titan. I copy the color value in the brightest area, and I adjust it in Photoshop to match that color value, and presto, it looks exactly like Titan. And so that's the kind of color calibration that, that the amateurs are interested in doing. That gets you something that looks like Titan, but it's not science, it's just pretty. As far as why the time isn't released, I'm afraid you'll have to ask the team leader for the imaging science subsystem instrument why that information is no longer available. It actually used to be available at the very beginning of the Cassini mission. They took that off the website. So I'm all for releasing as much metadata as possible. The metadata does eventually get released with the planetary data system release 9 to 12 months after it was taken. So yeah, it's regrettable. Back in the back there?
Yes, what did you mean by PDS quality imaging?
So when I say I'm talking about the archival data. I'm differentiating between the raw images, the auto-stretched, not flat-fielded, not calibrated, not geometrically corrected images that are released instantly, as opposed to the archival science data, which all NASA planetary science missions are required to deliver to the planetary data system after some proprietary period. It ranges from 3 to 12 months. And when those images are, one of the odd things about the NASA planetary data system is that different missions work out different agreements with NASA as to how processed that data has to be. So everybody's required to release their EDRs, the data that came down from the spacecraft, but higher level data, calibrated, flat-fielded, reprojected. Some missions release it and some don't, and it depends on the agreement that they worked out with NASA, and it depends on the personality of the principal investigator for that particular camera, unfortunately. Right here?
So I follow you on Twitter, and I often see images of curiosity on your Twitter feed that like take my breath away. And I always say, why am I not seeing this on JPL? Why am I not getting this both images from JPL?
Well, there's
just because they know that you guys are already doing it. They won't waste the time.
So the question is why JPL isn't formally releasing more of these. So, of course, all of these images are available on JPL's website. And so if you're interested in seeing daily images from Mars, you can just go to their website and find them. But what they don't release so frequently are the captioned, mosaicked, and other. And again, it depends on the mission. It depends on the personality of the principal investigator. For Mars Exploration Rover, when they landed, they had people at every day they had a science meeting, and they detailed a scientist who had to come up with a release for that day, and that one scientist would write a caption that day, and then the next day would be a different scientist. And so that way they shared out among the mission job of doing daily image releases from that spacecraft. Different missions, different personalities, different amount of releases. It's been harder to get processed image releases out of the Curiosity mission. Over here.
If you could send a mission anywhere in the solar system, where would you want to go?
I love this question because I love giving an answer that is different from most other people's answers. My answer is Uranus. I want an orbiter at Uranus because I think the moons are awesome. There's 5 different interesting moons that we've only seen at very low resolution. And because Uranus is in family with the kinds of exoplanets we've been discovering around all these other systems, and it's a type of planet that we haven't ever visited with an orbiting spacecraft before. I would also accept Neptune. Neptune has the bonus of having a Kuiper belt object captured and orbiting it, but it's farther away and takes longer to get to. So maybe we should build 2 of the same spacecraft and launch them both at the same time to get to Uranus and Neptune in the 2040s when they're both near equinox. Right? There we go. That's what I want.
For those of you that don't know, she was referring to the large moon Triton, which is a captured Kuiper belt object, which is bigger than Pluto.
That's right.
For the amateurs and enthusiasts who do so much work, if you can characterize them by their day jobs, I assume you get to know a number of them, the ones who post. Are you ever surprised at how far away their day jobs may veer from science?
Yeah, well, there's a wide variation. Probably the most common day job among the amateurs is programmer. And so they come into this with an interest in processing the data from the command line, and they do some interesting work that way. But there's a huge variety. I mean, one of the people whose work is featured most in this presentation is a guy named Ted Strike, who is a philosophy professor at Roane State Community College in Kentucky. And then there's another woman who's there's several photographers, so a lot of people come into it through photography, and it's really quite varied. You know, there's people who just have, you know, various office jobs who, for them, this is their excitement, this is their exploration, it's their chance to go explore other worlds on their vacations and weekends, so they enjoy it a lot.
Jesse, do we have any online questions? No? Okay. Klaus.
So of course these are all, you show beautiful images, lots of beautiful images. But of course, all spacecraft produce lots of other kinds of scientific data. I think one thing that come to mind for me is that I've been following the Voyager missions, for decades, and looking at the particle data as it's leaving the solar system. I find it very fascinating. That's just one example. I don't know if you have any thoughts about, is the public engaged in other types of maybe more esoteric data and something in that regard?
So there's two hurdles here to the public being interested in other kinds of data other than imaging data. One of them is the fact that so many people are motivated by that question, what would it look like if I were there? So they really do want image data of some kind. There is one kind of image data that's not widely used, and that's data from imaging spectrometers. Because those data sets are cubes, they're difficult to access. So if we wanted to get more people using that data, it would help to have either better browse tools, better tools for opening and converting that data, or archived versions of those data that might convert it to more familiar formats. So you might take a VIMS cube from Cassini. A VIMS is the visual imaging mapping spectrometer on Cassini, and you might make a hyperspectral calculate from its data set a true color picture that will actually do better at simulating the human eye color vision image of Saturn than, say, a three-filter imager would do. So that's one thing you can do. The other hurdle is that people would be super interested in, say, weather data or current magnetic field or current fields and particles environment, but only right now. So they want that exploration. I am there, I want to know what the spacecraft is experiencing right now. And so that means that the data has to be accessible instantly, so we're beginning to get that for image data, but that's not currently happening with most other kinds of data. For Curiosity, they are doing that with the weather data, though. So there's a website that you can go to get the weather report from Mars and see what the weather was on Curiosity yesterday, which is pretty cool. And so people do access other forms of data that way. You just have to make it available right now so they can follow the mission instantly, which is a little hard.
Any last questions?
Idle curiosity. You showed a bunch of images towards the end of the talk quite rapidly. Was the picture of Earth from discovered, or was it something?
No, the picture of Earth was from and I stuck that in there because it's from a Russian weather spacecraft. And there's just one Russian guy, Vitaly Egorov here, who runs a Russian language forum on spacecraft flight and does all of the same things that I do at unmanned spaceflight for this Russian forum. And one of his pet projects is to get this Russian Earth observation data. And he actually found images from this particular spacecraft. I forget the spacecraft, but he found images of the asteroid that entered and did all that damage in, I forget the name of the asteroid. No, not Tunga. Chelyabinsk. Yeah, and so he found the vapor trail and stuff in these Russian weather satellite images of Chelyabinsk. That was pretty cool.
All right. Let's thank our speaker one last time.